Hello, everybody. In this demo, we will be discussing our IMDb dataset. The main motive of this project was to predict the movie ratings using the IMDb dataset. The dataset that we had contains 28 variables around, which was about 10,000 movies spanning across 100 years in more than 50 countries. The first step we did was cleaning the data, pre-processing it, and extracting meaningful features from it, which also included null values and incorrect values. So before jumping on to the actual motive, I want to clarify here that this is a multinomial classification problem in which we are trying to predict the movie ratings based into three categories, such as bad, which is ranging from 0 to 6.3, average, which is ranging from 6.3 to 7, and good, which is ranging from 7 to 10. And I will be further discussing the binning in further detail. Let's go ahead with the agenda. The agenda is first of all data cleaning and pre-processing. The second we will be doing is data exploration and visualizations. Next up will come feature selection, which is a main topic, and then we will actually be applying the algorithms with k-fold cross validations. Some fine tunings will be happening here, and the last step would be that we will be concluding our core algorithm and what we learned from this project. So let's discuss the workflow here. We have the IMDb data set. We pre-processed it. By pre-processing, I mean that there were TSC files that we converted into CSV, and they were spread across a lot of files. So we had to dump it into one data frame and stuff like that. Then we had the feature extracting, the classifiers were used, and this is where our training dataset was used. Then we did some predictions in which our testing dataset was used, and finally we did some accuracy comparison between our four algorithms, and we'll be discussing that in further detail, and then there were final details. So let's go ahead and let's look into data pre-processing and data cleaning closely, and we'll be discussing here missing values, removing redundant values, removing outliers, and getting the right format is our main focus here. So data pre-processing, as I discussed, all the data was spread across multiple TSC files. We converted these TSC files into CSV files, and on the right you see the script that is actually reading the CSV files and putting it into data frames. Then we had data cleaning, and this is where we thoroughly checked for any illegal characters such as the A that you're seeing here, and the null values were a lot, and then there were duplicated values, which was a main challenge in this IMDb data set. Next up, we did data exploration and visualizations. So data exploration is the initial step in data analysis, where users explore a large data set in an unstructured way to uncover initial patterns, any characteristics, and points of interest. This process isn't meant to reveal every bit of information a data set holds, but rather to help create a broad picture of important trends and major points of study that we can do in greater detail later. So there are a couple of visualizations, and I won't go too much into detail of them, but just to tell you briefly that this is all we did. This is the visualizations of number of votes based on average ratings that you see here, and on the right you can see the genres and their distributions. Then we did another graph, which was a bar graph, and we can see here better how they were distributed, genre based on average ratings. Next up, we had number of votes versus average rating, and how they were, and we can see that mostly our data lies between 6.7 to 5-ish, and we can see we can get a major idea. Then we did a visualization of what is the most popular professions, and we figured out, which did not come as a surprise, that actors was the main profession. Now we come to where I discussed that how binning happened, and when we did it. So binning actually happens, and it is recommended to do an equal distribution of bins. So when we were binning, we actually figured out that this is our best way in which we could distribute them equally into equal bins. Although it looks very undistributed, but this is how our data set was, so we couldn't change it that way. On the right, you can see that it is actually a binomial distribution of the data, and it shows you the spread of that. And I think it gives you very good prediction or very good description on how it looks as to distribution of the movie ratings goes. So next up, let's go to feature selection. Feature selection is a very important step in data mining, and as we all know, selecting the right features in our data can mean the difference between a mediocre performance with long training times or a greater performance with short training times. It was that important, so we had to do three algorithms, and I'll be discussing that in greater detail as we go ahead. So the first one that we had was L1 regularized logistic regression, and in this particularly what happens that regularization consists in adding a penalty to different parameters of the machine learning model to reduce the freedom of the model, and in other words, also avoid overfitting. And how L1 regularization works is that it shrinks the coefficients to zero. So basically, any coefficient that we see that's not important in next slide, you will see that they'll be shifted to zero-ish. So we decided. And they work very good with the multinomial classifiers. So, and we had in this case good average pad. So it was a very good choice to do this L1 on our data set. We divided it as it is written here. Then we used some CV. The alpha was set to 1, and the family had to be set on multinomial since 3 bins. This was done, then the code is written. I won't go into detail because we've already talked about the code in our reports. But so on the right, you see here there's a list of features that were important, and as you can see, the ones that are set to 0, for example, start here is set to 0. I mean, that is not related to us. And for example, episode numbers are 0, so that's not related to us. However, a primary profession is actually related to me, and the number of votes is related to us, and language is related to us. So those were all chosen by this L1 as our important features. And and that is when we chose them. The one that you can see on the left were the chosen ones that came out after L1 regularized logistic regression. So next up, we did random forest and Baruta search. This is also, these both kinds of are the actually random forest algorithms that work in a similar set pattern. So basically how it happens is that the random forest algorithm generates a set of decision trees. um, each trade is trained on a different randomly chosen subset of data using different randomly chosen subsets of features. So each decision tree in random tree has a different training and testing set, and this is how it just checks the different attributes. So I don't think you can see this picture really well, but if you can see the data sets that are here very close and they have less kind of values are the ones that are not important, and the ones that you see have higher number of votes and higher number of data are chosen as our most important features when we applied the random forest here. And almost Baruta search kind of gave us some or less similar results, so we chose that. And how it chose was, we used it just gave finally it just gave 21 attributes because they held the maximum importance. So that's why we all did all of 3, and then we came up from 28 attributes, we switched out to 21 attributes that were actually from our max importance. So that's that from my side. I will now leave it here.
Okay, so the now we're going to talk about the different algorithms that we ran our data set on. And we also performed a k-fold cross validation on all the algorithms. The value for k that we set was on 10. Okay, now first model that we're going to talk about is the decision tree. So we trained our data set on this. The reason for using this algorithm is because the tree-based learning algorithms are greatly used for supervised learning techniques. The main idea is to branch the features based on certain conditions that either give us the desired outcome or further branches the tree nodes until the outcome is reached. So, as stated earlier, we split our data into training and testing with a 75-25 ratio, with 75% of the data as the training set and the remaining was considered as the testing set. The result was that the model could predict with an accuracy of 50%. So, to further see if we could get an optimized result, we performed a k-fold cross-validation on the model. There was what we observed was there was not much improvement in the overall accuracy of the model. That is, it just increased the accuracy from 50% to 51.37%. Uh, well, another major issue that we noticed while running decision tree was that it took really long to fit and predict the data. This was probably due to the number of features that we had taken. So, this model really took really long, to perform the computation, as well as it did not give us a really good accuracy. Okay, so now let's check out the other algorithm that we performed our data set to fit our model, which was a knife Bayes algorithm. Well, one of the major reasons for choosing this algorithm was that the knife Bayes classifier requires really less time to train the model. Hence, the computation time was drastically improved. Again, we trained our model by performing a tenfold cross-validation. What we observed is that not just the computation time but also the overall accuracy of the model was increased as compared to the decision tree, which was like close to 60%. So we could say that it performed better than the decision tree, but not as good, since we still get an overall error rate which was more than 40%. So next, we chose an algorithm that was not just computationally effective but also reduced the overall error rate, which was the random forest. So internally, how random forest works is that it consists of a large number of individual decision trees, and each of the tree in the random forest splits out a class prediction, and the class with the most votes becomes our model's prediction. In random forest, what we observed was sorry in random forest, approximately we split the data as 70% was considered as training and the remaining was used as a test set. Due to such randomization, during the tree split, the variable selection is not prone to overfit the training data, which is one of the major problems in all the remaining models. The resultant outcome was that the model gave us an overall accuracy of approximately 79%, which was pretty good, and also it was not that computationally expensive. Finally, we go on to our core algorithm, that is the k nearest neighbor algorithm. Well, the first step that we performed was, to evaluate a optimal value for k. So we ran this model for evaluating the k value from 1 to 10. We even evaluated our model with the value of k as 50, but that didn't really help us improve the accuracy of the model, and it took really long to execute. So, we thought of not having a really high value of k, and we set the value of k to an 8. Well, the overall accuracy that we observed was approximately 83%, and which gave us an error rate of 17%, which was pretty good. And for our data set, it was not that computationally expensive. So that is the reason we chose KNN for our core algorithm. Further, now since KNN was chosen our core algorithm, we thought of performing some fine-tuning steps for the algorithm. Okay. The first step that we performed was the bagging approach, which helped us reduce the variance and also reduce the overfitting. But for our data set, it didn't really work out that well, and the accuracy didn't have much improvement. However, when we ran our algorithm for checking the optimal value for k, we could see that it actually gave us a better accuracy, which increased from 82% to 86.76%, which was comparatively a really good, giving us an error rate of just 13%. So this model worked with giving the value of k as 8, which gave us the overall lowest error rate. So the overall, if we compare the algorithms, what we see is the decision tree actually took the longest to execute, and it gave us an accuracy which was worst as against the remaining algorithms. KNN, however, has one advantage, is that it gave us a very good accuracy, and the time that it took was comparatively less. However, KNN has one major disadvantage, is that if the data set is really big, it might take really long to execute, in which case random forest, that is our second best algorithm, would be our choice to go. But for our data set, KNN was an algorithm that we went with. You know, so to conclude, I would say that for our dataset, KNN could predict the movie ratings with approximately an 82% accuracy based on predictors such as actors, directors, runtime minutes, number of votes, etc. One of the most important factors that affects the movie ratings was the number of votes. Um, the remaining attributes such as start year, end year did not have much effect on the movie ratings. But we also observed that there was a strong correlation between different attributes like actors, directors, producers with movie ratings. Overall, we like after running all the four algorithms, we achieved an approximate of 70% of average model prediction accuracy with a 30% average model error rate for our dataset. We used different libraries such as CA tools, random forest, NLP, ggplots, Carrot, which are one of the most commonly used libraries in R. And that's it. Thank you so much. ठीक है उसको वैसे भी काटना पड़ेगा